Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Members, for this episode of CompTIA Linux Plus, and we're going to be managing kernel modules, and you're going to be watching and helping us as Don Pizzette presents. Don, good to see you, sir.
Hey, glad to be here, Zach. And this episode, we're going to take a look at something that's really important, a term that we throw around a lot, but don't put a lot of thought into, which is the kernel. The heart and soul of the Linux operating system is this kernel that does many, many things. And in this episode, we're going to learn about what it does, how it works, and we're going to see some of the things we can do to interact with it to either extend its functionality or just do some basic maintenance and kind of get a better idea of what's going on at the heart of our operating system, because it's super easy to just ignore it day after day and let it do its thing in the background. But as a support technician, we need to be familiar with that. So that's all stuff we're going to look at right here in this episode.
So Don, right up front, what are some of the things the kernel is responsible for?
It's almost easier to ask what are some things the kernel doesn't do, because it is involved in practically everything.
Yeah.
I've got a little diagram here. The kernel sits in between a ton of stuff, and it's involved in practically every operation we perform. Now, we don't see that. Like if I open up a terminal and start typing commands, I'm interacting with bash and xterm. But they're taking my commands and they're feeding it through their interpreters, and then their interpreters then sending it to the kernel. And the kernel is doing something with my commands. And that usually involves reaching out and talking to memory, either writing something to memory or getting something from memory, processes, spawning another application or interacting with an application that's already running, devices, interacting with hardware, sending a print job to a printer, putting a 3D graphic on a monitor, receiving keystrokes from a keyboard. It could be input or output. They all end up passing through. Resource allocation, divvying up RAM or CPU cycles or other things like DMAs and IRQs to make them available for systems. And then file system access. People are inputting and outputting data from disk storage, whether it's a RAID array or a single disk or whatever, a flash card, it's handling those communications. It's all passing through the kernel. And what it's doing is it's acting as an abstraction layer. I'll use printers as an example, right? Forever ago, way back in like the old WordPerfect days, if you wanted to print to a printer, your software had to have the printer hardware configured in the software itself. And so I might be able to fire up a Word program and print to a printer, but then if I fired up a web browser, it wasn't able to print because each program had to track it separately. It was a mess. Well, that all got abstracted out years and years ago, decades ago. And so now, when somebody makes a new piece of hardware, a new video card or RAM or something like that, they just have to make it where the kernel can talk to the video card or the kernel can talk to the printer. And then the software just has to know how to talk to the kernel. And as long as it can do that, the kernel acts as that middleman and exchanges the information. That makes it extremely important because the kernel actually does need to know what's going on in the hardware on your system so that the software doesn't have to worry about it. That's why it's so important.
So pretty much everything runs through it.
Yeah, I mean, it's hard to think of things that don't. There are times where you might have specialized programs that are able to use things like DMAs for direct memory access. That usually allows them to bypass the CPU, but even that doesn't bypass the kernel. It is involved in everything. In fact, if your kernel crashes, guess what? Your whole computer crashes. There's no operating without it. It's an essential piece. Now, when things are running, though, the kernel actually handles them a few different ways, right? And I've got another diagram here I want to show you. You've got your hardware. And I mentioned how the kernel is kind of like an abstraction layer between your software and your hardware. Well, the kernel is directly interacting with hardware and applications. And so it has what's called kernel space. This is where things execute with full system privileges, like full access to everything. They can do whatever they want. They can activate a sound card. They can shut down a network card. They can do anything. And at kernel space levels, you typically only have really critical software. Things like modules that tell the kernel how to function. Things like SE Linux that provide security. Drivers, the things that allow the kernel to talk to the hardware. That's going to have to be in kernel space. And then certain services like systemd, that will execute, that actually control the system, not what an individual user does. Now, all the stuff we run our graphical user interface, the X term I mentioned a moment ago, Firefox, if I launch it, all of that is running in what's called user space. And user space is unprivileged. It does not have full access. A web browser is not allowed to directly access a sound card.
Mm.
It's not. It has to go through the kernel, versus things in kernel space are allowed to directly access hardware. So that separation creates security and stability inside of Linux. It is very, very rare that your entire Linux distro will freeze and stop responding. It's very common to have an application crash. Everybody does that, right? An application crashes, but it doesn't take the system with it because it's being separated out from the hardware. And the kernel is what's managing this. When a program is being executed, the kernel is what's pushing it into user space or pushing it into kernel space and allowing those things to execute. So that's a big part of it. So technically the user space programs, they're not in kernel space, but the kernel is still being involved whenever they're run to be able to separate and isolate them out. But otherwise, everything else, if you kind of look at this diagram, everything else has to pass through kernel space in order to get to the hardware. If it doesn't have access to hardware, then it's not going to be able to work. Everything needs to have access to at least one piece of hardware, maybe the keyboard so you can send commands to it, or the monitor so you can see what's happening. If it has no hardware, it's not going to be very effective. Even network services like a web server still has to have access to the network adapter, right? So the kernel is always going to be involved.
Are there different kinds of kernels available?
I'm going to say yes to that.
Okay.
Technically, this is Linux Plus, right? In the Linux world, there's only one kernel. I mean, there's multiple versions of it, but there's really just one kernel that we run, the one that Linus Torvalds maintains and is the heart of every Linux distro. But outside of the Linux world, there's plenty of kernels, right? In fact, all the BSDs that are out there, FreeBSD, OpenBSD, they use a different kernel. Apple with Mac OS, they use their own kernel. It's called Darwin. Windows has their own kernel, the NT kernel. So each operating system can have its own different kernel. But in the Linux world, everybody's settled on Linux. In fact, when we say Linux, we're not actually talking about the operating system. The operating system would technically be called like GNU Linux. It's the Linux kernel combined with the GNU utilities. I think we talked about that in another episode too.
We did.
So that's really what we're running here. Now, one thing I do want to highlight though is that there are variations in the kernels that are available between these different vendors, right? So you'll hear people describe the Linux kernel as a monolithic kernel, but you'll also hear the term microkernel thrown around. All right, Linux is a monolithic kernel, not a microkernel. These are the two different types. With a monolithic kernel, the kernel and all of the modules that are attached to it run in kernel space, and they go into RAM, right? So the kernel is actually much larger in RAM than it is on disk. On disk, it's, I don't know, like a megabyte and a half. Not very big at all, right? But once it goes into RAM, it balloons in size because all the drivers and other things get attached to it and it gets much larger, right? Monolithic kernels are fast because all of their modules and drivers are stored right there in RAM alongside the kernel, okay? But they're considered less secure. And that's because if there's a vulnerability in a driver or a vulnerability inside of some module, it's loaded in kernel space right next to the monolithic kernel. And they're also bigger so they consume more RAM. So if you have a ton of memory, you don't care about that. But if you're on a real tight memory budget, like you're doing an embedded device, that monolithic kernel consumes a good bit of RAM. And so now you've got to make sure you plan for that with your hardware. You can't just say, oh, I'm going to run 4 megabytes of memory, because a monolithic kernel can easily consume 4 megabytes of memory. But if you have 4 gigs of memory, 4 megs is nothing. You don't even bat an eye at that. It's no big deal. Now, microkernels, we don't really see, you certainly don't see in the Linux world. It's monolithic. GNU Herd pops to mind as one that uses a microkernel. And that's where they keep the kernel and kernel space as small as possible, very, very small. All of their modules and drivers are actually loaded in user space. They're loaded separate. That makes them technically more stable because the kernel's not going to fall if a user space thing fails. But at the same time, they're slower. They're slower because those other modules are stored in a separate area of memory. They're isolated from the kernel space. So there's a bit of a trade-off, between stability and speed. And in the Linux world, and in the Apple world, and in the Windows world, they've all gone monolithic. So that's kind of the choice that most people stand with. But you'll hear those terms batted around a bit. Just know that Linux is not a microkernel.
So how can we see information about our kernel?
If you want to see it, okay, so I mentioned kernel modules. Right? And the kernel itself, actually, here, let me get a terminal fired up. It's not as glorious as what you might think when you go in here and kind of poke around. If you want to see what kernel you're running, you can run a command uname dash a, right? Uname says, tell me the Unix name of this system, and that means tell me about the kernel, right? Now, if you just run it by itself, you'll see some limited information. It says Linux. All right, well, I kind of already knew I was on Linux. So if you do dash A, that says tell me all of the details about this. And when I run that, now I see a heck of a lot more, right?
Mhm.
And the important part for me is this guy right here. I can see that this is running Linux kernel 3.10.0, and then it's got, sub-release information on top of that, and then the date it was compiled and all that other stuff. Now, some of you might be watching this and thinking, oh my gosh, is Don running 3.10? That's ancient, right? Because the current version of Linux is 4.0. Well, kernels are not updated as rapidly as everything else on your system. When you replace the kernel, that's a big deal. And if there's some kind of a bug or a vulnerability or whatever, that has a huge effect. I'm running CentOS. CentOS is based on the Red Hat Enterprise Linux distribution. And with RHEL, Red Hat, they do stability over functionality. They want stable, rock solid systems you can count on in a business. So they don't jump on the latest and greatest. If you install Ubuntu, they're a lot more aggressive. They will try and go to the latest and greatest. And you might see that you're running 3.20, or actually, I think 3.19 was the highest before they jumped to 4.0. Or hang on, I'm back a bit because now I think 5.0 was just released. Was it yesterday? So
Wow.
big jump. So they went all the way to 4.19 before jumping up from there. They don't like to go above 20 on these, or at least Linus Torvalds doesn't. So don't be surprised, though, if you see an older kernel number like that. You might have the latest and greatest software. You might have the current version of Apache and so on, but your kernel is an older one because it's the most stable and tested, right? You do still want to check for updates, but this is where we can see what kernel we're running. Now, if I wanted to see the actual files that go on behind this, there are a few different places. If you go into /boot right there and take a look, inside of /boot, you're going to see a number of files. We're going to talk more about these in the next episode when we talk about the Linux boot order. But in here, you'll see this VM Linux with a Z, right? That VM Linux, that right there is your kernel file that gets loaded when you boot it up. So this is the file itself right here. And I've got more than one. That just means I took a system update. And it always saves the previous version. In case there's a problem, I can roll back. When you boot your system, you see a little menu and you can pick your previous version. If we look at the long file listing here, let me do a LH on that. These kernel files are 6.4 megabytes in size. Pretty small for something that's going to power your whole system. And it is compressed. It gets bigger in RAM. But that's the kernel. And then all those modules and other things I mentioned, you can find those if you go into /usr/lib/modules. That folder right there contains the modules for your particular kernel. Now, I've got two kernels on my system because of that update, so I need to change into a subdirectory here, that one. And as I poke around in here, I'll start to see those modules, and you'll see more kernel information in here with the built-in modules, updates, other things. All of that's coming from right here, and it all gets built together in RAM to run as one big fat kernel. It takes the 6.4 megabyte file and combines it with the modules defined here to put them in RAM. There is an easier way to see this. Oh, actually, before I move out of here, I'm in /user/lib/modules. Some distros actually put it in a slightly different place. They get rid of the /usr. So you might need to go to /lib/modules and poke around in there. In fact, on CentOS, I believe that's a symlink. Oh, actually, I know it's a symlink. If we take a look at that lib folder, see how it's symlinked to /user/lib. So they've symlinked it here. But some distros just actually put it in /lib/modules. So be aware of that. Another thing we can do, though, is there's a command we can use to pull up our modules, lsmod. And this command is more useful because you might have modules on your hard drive that aren't actually loaded and active. You might have modules to power certain hardware that's not plugged in. And if that's the case, you'll see the file, but you don't actually know if it's loaded or not. With lsmod, you can run it and you'll see all the modules and their status. Let me pipe that into the less command so that we can see it from the top. And what you'll see is the module, its size, and how many other modules are using it. So if it's used by something else, like my first one, this TCP/LP, is not being used by any other modules. It's a standalone entity. But some have a lot of dependencies, like IPT Masquerade. 3 other modules depend on this one, so it's kind of an important one. But as I look down here, these are all the modules that are being stuck on to my kernel. My kernel doesn't have an IP firewall built into the kernel. So we have a module for IP tables that's being added on. And I can see it right here, IP tables and IP6 tables for IPv4 and IPv6. So that's being added onto that kernel. And somewhere in here, I'll see hardware drivers and other things. I'm sure I'm skimming over. Well, here's sound stuff, right? Sound codecs and other hardware that we want to interact with. And you'll see other things along that nature. It's a pretty good sized list there. This is all extending the functionality of our kernel and making it do a lot more. And if you ever want to learn more about one, like here I see this E1000 module, all right? That's the driver for an Intel E1000 network adapter. So that's my network adapter driver. Now, I know that because I've got it memorized, but if I didn't know that, if I looked at it and I said, well, what is E1000, right? There's a utility you can use called modinfo. And if you say modinfo and type like E1000, you can run it and it will tell you more about that module. And so I get the listing right here, and right here at the top, I can see that this is the Intel Pro 1000 network driver. So now that mystery has been revealed, and I can see what version it is. I know if I can go and check for updates, and then it gives me other aliases because there's more than one network adapter that uses that same module, and then other details about like where it came from and so on, all found right there. Now I did modinfo and specified the name because it was loaded. If it wasn't loaded, I could actually specify the file name that module comes from. If you're poking around in /user/lib/modules, you'll see the file names. Modinfo works with those file names as well, and it'll give you the same details back, and you can figure out what's going on there. A couple other commands we can use if there's a module that we want to install. So I have a new network card driver, and I go to the vendor's website. I download the driver, and I need to install it. You do insmod followed by the file name, and that would install it and put it in the system. It won't come active unless the hardware is actually detected, but you can install the module. And then you can get rid of modules with rmmod, and then you would specify the name. So I can do rmmod E1000, which I don't want to do because that's my actual network adapter. But if I removed it, then that would take that module out, and that hardware would no longer be supported. So I kind of rocketed through those. There was modinfo to learn about mods, lsmod to see which mods are present on the system. There was rmmod to remove one, and then insmod to install one. Sorry, those were the four. I had brain freeze there for a moment. So those are some of the different ways we can kind of manipulate those modules and see what's going on inside of our kernel.
So once a module is installed, how do we activate it?
All right, so the easiest way to activate it is to reboot.
Reboot?
We don't necessarily want to do that, though. But when the system boots up, it does hardware detection. And it looks at your hardware, right? The whole D-message and D-bus system goes. It detects your hardware. And then if it finds some weird hardware, it gets an ID. See all these PCI IDs up here? It gets an ID from that hardware.
Right.
And then it looks for a module that matches that ID. And so when it finds the module you just installed, it brings it online. Okay? But what if it's hot plug hardware? Like if I plug in a USB key, I don't want to reboot for the USB key to be detected. That would be really annoying. So instead, we can tell the system to probe for new hardware. And you do that with a utility called modprobe. Let me just pull up the man page for modprobe. And what it does is it takes a look at the hardware that's present right now and all of the modules that are present. And then if it sees hardware that's missing a module, it'll load the module. And if it sees a module that's loaded but the hardware is gone, it'll remove the module. So it kind of keeps the system updated. And it allows us to do this while the system is running. Remember, when Unix was created back in the 1970s, there was no such thing as hot plug hardware back then. Hot plug hardware has really only been popularized since the 1990s, decades after Unix was created. So being able to detect hardware that changes while the system is on was something that had to be retrofitted and added in. And even when Linux was created in the early 1990s, USB was really just an idea then. It wasn't super popularized until the late 1990s. So modprobe is what fixes that. Modprobe is what lets us go in and see and change things. Now, modprobe can be kind of messed with a few different ways. If you have something specific you want it to do, like some people say, all right, I've got some hardware that I don't want loaded. Maybe you've got 2 video cards. You got a video card that's built into your motherboard, and you've got an add-in card. And the internal video card is messing with your add-in card. So you don't want the modules for that internal card to be detected. You might want to tell modprobe to not load it. And so you can communicate that to it. It has a configuration file. If you go into /etc/modprobe.d, that folder right there. Actually, there is an older file. Let me see if it's even on the system. /etc/modprobe.conf. All right, so I don't have that one. So modprobe.conf, that's what used to be used. And it was just a single file, and you'd put all of your modprobe data right inside of that modprobe.conf file inside of /etc. But in most modern distros, it's been moved, like mine, where it's /etc/modprobe.d. And inside of there, you can create any number of .conf files, and you can name them. So if I wanted to block my internal video, I could create a internalvideo.conf. And then inside of it, put in rules or instructions for modprobe not to do certain things. Looking at mine, here we've got like firewall D, right? So I'm running the firewall daemon to protect my network adapter. And that's a module that needs to be loaded to the kernel because it doesn't have a firewall by default. So if we take a look at that file, inside of it, I'm not seeing a whole lot, really just one line. And that one line, I get my heads over part of it, but you'll see where it says install nf_contract, ignore install nf. It's going on and giving it instructions. It's telling it to install a module. And that module is the NetFilter connection tracker, nf_contract. So it's telling it to load that. That's an instruction it wouldn't normally know to do because this is software. With hardware, it can detect it. It can say, oh, look, here's this network card. I wonder if I need a driver for it, right? But with software, it doesn't know, should I load this software or not? So this is the instruction that tells it to do that. And so you can get in here and kind of manipulate that if you want. Let's say, for example, that Bluetooth. I want to load the Bluetooth driver on my system. Now, I don't think it's actually loaded. If I do an ls mod, and I'm going to grep BT USB, all right, Bluetooth USB. So looking, oh shoot, I actually do have it. So, all right, I've already got that one loaded. If I didn't have Bluetooth, then that might not be loaded, and I might want to force it to load, or maybe it's not being detected right, and so I just want to force it to be loaded so that it's already there. Well, I could create a file and force that one to be loaded. The way you would do that is you would create a comp file in here, and well, there's a few ways to do it. If the module is already present, it can actually be really easy to load it. I'm going to create a file. Let me sudo this. I'm going to do sudo vim, and I'll just call this one btusb.conf. All right. And inside of that file, I'm just going to add one simple entry. I'm going to say alias blue btusb. All right. It's already loading. So I'm just going to add an alias here that's easier for me to remember. Maybe I can't remember btusb. I can remember the word blue. That's easy, right? So I'm going to set that instruction. Now, it's got an alias. And so it knows whenever I say blue, I actually mean btusb. And so I can come in and say sudo modprobe -a blue. I'm telling it to activate the module blue. And it's going to look in its conf file and see that's an alias for btusb. And then it's going to look and make sure if there is a btusb module, it's going to load it and get it put in place. So when I run that, I'm not going to see much change here because I already had it running, but it would bring it up and put that in place. I suppose I could do like an rm mod btusb and take that out. So there, I just removed the module. And when I look, see how btusb is not coming back? It's completely unloaded. And I can tell modprobe, go ahead and activate blue. It's going to see that alias, recognize what it is, and load those modules back. And now they're all back up and running. There were multiple modules tied together because of dependencies, right? But I only had to call that alias, and they all came back. So that's kind of how we can manipulate modprobe, all without having to reboot my computer. Technically, I just turned off my Bluetooth and then turned it back on again, all right there in software without rebooting.
Is there anything else we may need to configure for our kernel? Don?
There's a few other things. I've been showing modules. Modules, extend functionality of the kernel, but there is functionality in the kernel itself that we may need to manipulate, and there's things called kernel options. When you're in your bootloader, which we'll look at in another episode, there's kernel options you can pass that tell it things like what resolution your monitor should be during the boot screens, right? X Windows takes over later, but what resolution your console should be, or whether your console should be a monitor or a serial port, right? A lot of servers or appliances will actually export all their data on a serial port, and those are options that you can pass to the kernel. You do those at boot, so those are handled in a different system. But if you want to see those options, there's a neat utility you can use, which is sysctl. And that's the system control, which lets you interact with the kernel. And if I do a -A, it's kind of like uname -A, show me everything about the kernel. sysctl-a tells me to show it, or tells it to show me all the parameters that are being passed to the kernel. And when you run that, you'll see every single parameter that is being passed. And these parameters manipulate the kernel and the modules that are attached to it. So I'm seeing tons of IPv4 stuff for the firewall, IPv6 stuff, and then right here comes my kernel settings. And these are things that dictate how many CPUs it's got, how many cores it has, not how many it physically has, but how many it logically recognizes. Is it going to use them? If there's extra monitors, you can shut extra monitors off in here. You can shut hardware off. There's all sorts of things that you can do inside of these kernel options. Most of them are well documented inside of the kernel documentation. If you go to the Linux GitHub repository or the Git repository, you can find it there. But otherwise, they're kind of named where you can sort of know what they do. But many of them are really tied to performance. You may have to come in here and tweak to optimize performance in a server in a certain situation. We'll see a few examples of that in the bootloader episode, so stay tuned for that one.
Managing kernel modules, another awesome episode. Thank you so much, Don. Wonderful as usual. And would you like to say anything else?
Probably not on the exam, but in real life, if you ever get squirrely, it can be kind of fun to compile your own kernel. When you compile a kernel, what you're doing is building the actual VM Linux file, and you can take modules that you know you need and build them right into that file. And that actually improves performance a little bit. If you know exactly what hardware you're going to have, you can kind of pre-build that in. It's a kind of fun experiment to do at least once. It's a nightmare to maintain, though, because every time a kernel update comes out, you have to recompile, and that's really frustrating. So I don't normally do that in production, even though I know I could get a little more performance out of it. But it's fun to do, and you'll learn about the kernel as you compile it.
Wonderful information, Don. Thank you so much. And you know what else is wonderful information? Watch every single episode of CompTIA Linux Plus. It's going to help you now and in the future, and that exam is inevitable. You know it is. So keep studying, keep learning, and take advantage of the supplementary information in our course library. You're going to be glad you did. Check it out. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again soon.
Thank you for watching IT Pro TV.